Hello dear grade 6 children. Today you all are here with me to learn the third lesson of science. That is water as a natural resource. So you all know that water is a basic need. We can't live without water, and water is very important in our day-to-day life activities. So what are we going to learn under this lesson, children? We will see. So we are going to learn states of water. Now we all know that there are 3 states of matter. So we are going to learn water also has all 3 states, right? And we are going to learn types of water based on availability. So in earth, water can present as different ways. We are going to learn what are those ways. And types of water based on salinity. Now we are going to learn under this topic that there are different salts dissolved in water, and based on the amount of salts dissolved in water, there are different types of water, right? And importance of water. You all know that water is very important in our day-to-day activities. And finally, we are going to learn water is a limited resource. So we will start the work. What can you see in this picture, children? We can see there are so many places with water. So if you go out, when you look in the environment, you know that there are so many places with water. What are those places, children? Here we can see a river and wells. Some of you have wells at home, right? And waterfalls, and we have ponds. Now man-made ponds are there and natural ponds also there. Apart from these things, what are the other places we can find water? Yes, you might say that there are seas and there are streams. Those are also the places with water. So we will write down these things, children. Here we have water present in rivers and wells, and in waterfalls, right, in ponds. So what are the other places, children? Even though the pictures are not given here, we know in the ocean. What are the other places? Tanks. So there are so many places that we can find water. So in day-to-day life, if you have wells at home, you can get water from wells, right? Or you can get water from rivers or ponds, etc. Understand? So what are the other ways that water can present, children? Now we know that when we think about these places, water present as liquids. Is there other forms of water? We will go and find this now. Right. Now we have to do the first experiment under this lesson. What is that? Identify the states of water. Do you remember in the second lesson we learned that matter has 3 states? What are those 3 states? Yes, that is solids, liquids and gases. Right? So under this experiment, we are going to find out whether water also present in all 3 states or not. Right, children? So I hope you remember what are the steps coming under an experiment. So the first thing you have to write is the title, that is under experiment. Here the title is identifying the states of water, and then you have to write materials, right? So what are the materials you need here? We need some ice cubes, and we need a test tube, and we need a Bunsen burner. Understand? We will write down this. Ice cubes, we need a test tube, and we need a Bunsen burner. Right? What do we have to do in this experiment, children? We will see it in the next step. Under the method, a diagram is given. Now we already know that under the method, it's very easy if you draw the diagram and then explain. So the number of steps that you have to write reduces when you draw a diagram. And remember, this diagram should be a labeled one so that you all can understand it very well, right? So what is this diagram? Here we have the Bunsen burner. Here we have the test tube, and in the test tube there are ice cubes. I'm going to name that as well. Ice cubes. Right? And test tube holder. Now you are going to heat this test tube. You can't just hold it with your hands. To protect your hands, you have to use this special equipment called test tube holder. Okay. So what you have to do is, you have to put some ice cubes into the test tube, and you have to heat the test tube with ice cubes using the Bunsen burner. Understand? We will write down that. Under the method, set the apparatus as shown in the diagram. Shown in the diagram, and heat the test tube with ice. Right. Set the apparatus as shown in the diagram and heat the test tube with ice. So now we are going to do this experiment. Okay children, now we are going to identify states of water. So we learned that there are 3 different states of matter: solids, liquids and gases. So in water we are going to identify whether all these 3 states are there or not. So here we have some ice cubes. This is the solid states of water. So I am going to take some ice cubes to this boiling tube. Now this is the boiling tube children. Now here we have to heat this ice. Because I have to heat, I am going to use a boiling tube. Why can't I use a test tube? That is because test tube cannot withstand heat, but boiling tube can withstand heat. So I am going to hold it with the handle, and I am going to heat this ice. You can see it is solid. Ice is here. Now I am going to heat it. So as a safety measure, you always have to hold the mouth of the boiling tube away from you when you heat something. So if you observe, you can see this ice melts and it becomes water. So ice is the solid state of water, and water, this is the liquid state. Most of the time in day-to-day life, we use the liquid state of water. Now there's no ice, so all turn into liquid. I'm going to heat it further. Right. So observe clearly children. The water is starting to boil. Right. Now water is boiling. You all can see steam goes out. What is this steam children? This is the gaseous state of water. Steam is the gaseous state of water. When water boils, steam releases. This is water vapor or gaseous state of water. What is the conclusion that we can come up with after doing this experiment? Water has all 3 states: solids, liquids and gases. Did you see the experiment? Did you observe carefully what happened when I was doing the experiment? I hope so. So what happened children? I showed you that you have to take some ice cubes into the test tube and you have to heat it using the Bunsen burner. Right? So what happened when we heat the ice cubes children? Yes, ice cubes melt, and ice cubes melt and turn into liquid water. Right? So what happens when you heat the ice cubes? Ice cubes, now I will indicate by using these arrows that we are heating. When you heat ice cubes, what happens? It will turn into liquid water. Right? It will turn into liquid water. So when you heat this liquid water, what happens? It will form water vapor. It will boil and form water vapor. Okay, so we will write down these two steps. Step 1, when ice cubes are heated, they melt and turn into liquid water. Right? What is step 2? When liquid water is heated further, liquid water is heated further, water boils and steam is formed. Understand, children? So these are the observations, the things we saw in the experiment, right? So what can you decide? What is the conclusion that you can come up with after doing this experiment, children? Now we are doing this experiment to identify the states of water. So what are the states of matter again? Those are solids, liquids and gases. So what about water? When we take water, can we find water also under the same states, children? Yes, I'm sure now you understand this. When we take ice, ice is the solid form of water. What about the liquid water? The drinking water, that is the liquid state. And when we heat water, what happens? It starts boiling and steam is produced. What is this steam, children? That is the gaseous state of water. Understand? Therefore, it is very clear that water can present in all three states. What are the states? Solids, liquids and gases. So that is the conclusion of the experiment, right? We will write that. Water present in all three states. What are those three states? Solid form of water, liquid form of water, and as a gas also water present. Right? Water present in all three states: solids, liquid and gas. So what is the solid form of water? That is ice. Liquid water is the liquid form. We normally call it water. What is the gaseous form of water? Steam or even water vapor in the environment. Okay. So here under this experiment I will write steam. And we are going to learn about water vapor as well. Therefore, I will mention that also here. Did you understand this experiment, children? So we did all these steps and we observed what are the things take place during the experiment, right? And the conclusion is water present in all three states. Understand? I hope so. Right, children. So again here we have the states of water. Now we know what are the states of water. Water can present in all three states. What are the states? Solids, liquids and gases. So here using this picture, it's very easy to understand. Water present in all three states. Look at this picture. Water present as ice, that is the solid form of water. And here liquid water is the liquid form of water. And water vapor or steam is the gaseous state of water. Understand? So how do we convert this ice into water and liquid water into water vapor? What did we do here? I am going to show you this using an equation so that you can memorize this really well. Okay? Right. Right. So how do you turn ice into liquid water? Ice turns into liquid water. Now ice is the solid form of water. Understand? Liquid water is the liquid form of water. Right. How do you turn ice into liquid water? Yes, that is by heating. On the arrow I am going to write by heating. When you heat ice, it turns into liquid water. So when you further heat this liquid water, what happens? It turns into steam. That is the gaseous state of water. Right? Solid form is ice, liquid form is liquid water, gaseous state is steam. Understand? So how do you convert, how do you turn this liquid water into steam? That is also by heating. Okay, so by heating or by increasing the temperature, you can turn ice into liquid water. Again, when you further heat liquid water, it turns into steam. Okay, this is very easy, right? We will see the other one. So what are the physical states of water, children? Solids, liquids and gases. I hope this is very clear now, children. Now I will ask one question. Look at this one. I told you we can turn this ice into liquid water by heating, and again liquid water into steam by heating. So is there a way that you can turn this steam back to liquid water and liquid water back into ice? What is the method, children? Now you already know. Now most of you have refrigerators, right? So if you store this liquid water at liquid state in the freezer part, what will happen? It will turn into ice. So when you store this water in the freezer part of the fridge, what actually happens? The temperature reduces. Okay? So thereby it's very clear, by cooling, by the cooling process, you can turn liquid water into ice. Understand? So in the same way, steam also can be converted to liquid water again by cooling. Understand? So by heating, ice turns into liquid water and liquid water turns into steam. And by cooling, steam turns into liquid water, and when you cool liquid water, it turns back into ice. We are going to write that as well. Okay? So here I will write ice. Ice is the solid form. Okay? And liquid water. It is the liquid form. Okay? Steam, or you can say even water vapor. steam or water vapor, it is the gaseous state. So you can convert ice into liquid water by heating, liquid water into steam by heating. So how do you convert this steam or water vapor into liquid water? That is by cooling, the opposite of heating. The other side, cooling. And again, liquid water into ice, that is also by cooling. Is this clear, children? I hope this is very clear. So when you study this equation, it's very clear that you can convert ice into liquid water into steam or water vapor by heating it, and you can again convert this steam or water vapor into liquid water and water into ice by cooling. Understand, children? I hope so. Now we learned that water can present in all three states, solids, liquids and gases. Understand? Now we are going to learn what are the examples for these solids, liquids and gases. So we have water in solid state. Look at these pictures. These are the places where you can find water in solid state. What is this, children? Now you can see it is a big ice mountain. What is this? This is known as a glacier. Can we find glaciers in Sri Lanka? We cannot, because Sri Lanka is a country which is located near the equator. Therefore, temperature in our country is comparatively higher than the other countries, right? Where the other countries which present in the polar regions. Okay, so where can we find these glaciers, children? Yes, we can find glaciers in polar regions. Okay, so what is the second picture? The next solid state is ice. Understand? So this we have seen ice in day-to-day life. We use ice when we make juice, and sometimes when we have brews or something, we use ice, right? And what is this? This is snow. So again, we can't find snow in our country, but I'm sure you have seen snow and these glaciers even in pictures or videos. Okay, so these are the solid states of water. We will write this. Glaciers, ice, snow. Understand? So we will see what are the liquid states, examples for liquid states now. Here, what are these places? There are so many places we have seen where water present in its liquid state. What are these places, children? This is a river, this is wells. I'm sure some of your houses, there are wells, right? And this is the sea and reservoir or tanks. Okay, there are so many places where we can find water in its liquid state. What are the other places which are not given in these pictures? Yes, waterfalls also correct. Streams also correct, right? So we will write this as well. Rivers. Okay. Wells. Here sea. And here we have tanks. And we can write other places as well. Waterfalls, streams, okay, children, there are many places where we can find water in its liquid state. What about the gaseous state, children? We will see. Water in gaseous state. There are two ways that water present under its gaseous state, that is steam and water vapor. Now we already discussed about steam. When you boil water, when you heat liquid water, what happens? It starts boiling and then steam will form. Understand? So most of the time when your mother, when she is cooking or when she boils water, you must have seen steam, right? What about water vapor? Water exists in the atmosphere as water vapor. Water vapor is part of our air. Now you will know that air is a mixture of different gases. Water vapor is also one type of gaseous state present in that air or atmosphere. Okay, so when it rains and during the night time and in the early morning, the amount of water vapor present in the atmosphere is higher than the other times. So what are the other times that water vapor, the amount of water vapor is low? Yes, during drought seasons, when it is very sunny, the water vapor evaporates because of the heat of the sun. So during those times, the water vapor present in the atmosphere is less than the other times. Understand? I hope this is very clear. So we all know that water can present in solid state, liquid state and gaseous state. Now we are going to do an experiment to prove that there is water vapor present in the atmosphere, right? As I told you, we are going to do this experiment to prove that there is water vapor present in the atmosphere. Okay, so what is the experiment? What is the title of our experiment? Testing whether there is water vapor in the atmosphere, right? So then we have to write down the materials we need. What are the materials we need? What are the things we need here? We need an empty glass, a dry glass. Okay, and we need some ice cubes, some water and a piece of cardboard. Understand? So we will write down a glass, we need a glass and some ice cubes and some water and a piece of cardboard. Right. So how do we do this experiment, children? We will go see. Here we have the method. You can see the diagram present here. This is water, ice cubes, and we will label the other parts as well. This is the glass and cardboard. Okay, so what do we have to do here? First of all, we have to take the glass and fill half of the glass with water. Then we have to cover or close the mouth of the glass with the cardboard and we have to leave it for some time and observe what happens. After that, we have to open the glass again. To the same amount of water, we have to put some ice cubes and again you have to close the glass with the piece of cardboard and you have to observe, right? We will write those steps now. Fill half of the glass with water, then close it with the piece of cardboard. And observe. What is the second step? You have to put some ice cubes into the same glass and then again close it and observe. Number 2. Put some ice cubes into the same glass. Same glass with water. Close it with the piece of cardboard and observe. Understand? Fill half of the glass with water, close it with the piece of cardboard and observe. Step 2. Put some ice cubes into the same glass with water, close it with the piece of cardboard and observe. Now we will go into the lab and do the experiment. Okay children, now we are going to test whether the atmosphere contains water vapor. So in order to do this experiment, I have two beakers. In this beaker we have some water at room temperature and we have some ice cubes here. So first of all, I am going to take this water and we are going to observe if something happens if I close this beaker with a piece of cardboard like this. So observe if any change takes place around the beaker. Can you all see any change, children? Observe carefully. Observe around the beaker, on the walls of the beaker, if something happens, if any change takes place. Right. So you all can see there's no change takes place if we take just this water and close it with the piece of cardboard. Now I'm going to put some ice cubes to this beaker. We are going to transfer these ice cubes to this beaker and I'm going to close this and you all have to observe this carefully. What happens? Can you all see there's a slight change here, children? Earlier, when only water was there, this beaker was very transparent, right? So can you see it becomes a little cloudy or misty? The transparent nature reduces. It becomes less transparent. Can you all see clearly? Observe carefully. So what is this change, children? You all can see if I take my finger like this, draw lines, you all can see there's a change here, right? You can clearly see the lines. Observe very carefully what happens to this beaker with time. So can you all see that tiny water droplets form on the wall of the beaker? Can you all see these tiny water droplets, children? There are some water droplets. Earlier it was very dry, outside was very dry without any water, but now you all can see clearly water droplets form on the beaker, the outer wall of the beaker. Observe this side as well. Now those tiny water droplets, it was very tiny before. Now it's a little bigger. So here if you see this place, you can see bigger water droplets. So you can see this water, it flowing down through the wall. Right. So it's very clear, children, before when ice was not there was no change in this beaker, but when we put some ice, after a little while when you observe what happened, we could observe water droplets outside. So what is the reason for this change, children? The reason is earlier water was at, before we put ice, water was at room temperature. Right, room temperature means that normal temperature in the environment, right? So the temperature of water and temperature of the atmosphere, there was no difference. But when I put some ice, what happened? The temperature of the water reduces, right? So water cools down, and that temperature, because of that less temperature, these walls of the beak also cools down, right? So you know that even if we can't see, now we already have learned, so atmosphere or air present around this beaker. Okay, so what happens? Water present in the atmosphere, water present in this atmosphere around this beaker, when water vapor cools down, it condenses and it becomes to these water droplets. It turns into these water droplets. That is because gaseous state, in this gaseous water or water vapor, it cools down, it turns into its liquid state, right? So that is why we can see these water droplets after cooling down. So using this experiment, we can make sure, we can come into a conclusion that atmosphere contains water vapor. When it contacts with the walls of the beaker, what happens? It cools down and it condenses. That is why that gaseous water turns into liquid water and forms droplets here. So what is the conclusion that we can come up with, children? Atmosphere contains water vapor. Right, children? So did you see the experiment? Did you observe what happened when I was explaining the experiment, children? I hope so. So what happened in the first step? Fill half of the glass with water, close it with a piece of cardboard and observe. Did you observe? Did something happen? Nothing happened, right? And what happened in the second instance? When you put ice cubes and close it, what happened? You saw that water droplets form on the outer surface of the glass. We will write down that. So in the first instance, no change. No change. Nothing happens. Number 2, the second one, when you put ice cubes, water droplets can be seen on the outer surface. Outer surface of the glass. So do you remember I told you we have to take a dry glass. But when you are doing this experiment, we can see water droplets are formed on the outer surface of the glass, right? So what is the reason for this observation, children? I was explained when I was doing the experiment the reason for this observation. What is the reason, children? Because when we put ice into this glass, the glass becomes very cool. It is when you consider about the temperature of the glass is less than that of the atmosphere. It means the glass is cooler than the environment. So then what happens? Water vapor present in the atmosphere, it contacts on this surface of the glass and it condenses and water droplets are formed. So it is very clear that in order to form water droplets, there should be water vapor in the atmosphere, right? So it's very clear that there is water vapor in the atmosphere. That is the conclusion. Can you understand that? I hope so. Right. So we will write the conclusion. I'm going to write it as a description because Otherwise, if I write only the final conclusion, it's not that clear, right? So I'm going to write the surface of the glass is cooler than the atmosphere. Therefore, water vapor condenses and water droplets are formed. So what is the meaning of condensing? Condensing means gaseous substance turns into a liquid. So we learned earlier that by cooling steam or cooling water vapor, we can convert it into liquid water. So this water droplets means liquid water, right? So the surface of the glass is cooler than the atmosphere. Therefore, water vapor condenses and water droplets are formed. Therefore, it is very clear that atmosphere contains water vapor. Therefore, there is water vapor in the atmosphere. Understand? Now remember, this last sentence is the conclusion, right? This last sentence is the conclusion. I wrote all this description so that you can understand this better. Right, children? I hope you understood this part. Now we are going to discuss about the types of water based on availability. Now we already know that when you consider about the states of water, there are 3 states. What are the states of water? Solids, liquids and gas. Understand? Now we are going to categorize water based on the availability. So what is this, children? We will go through this. What happens to the raindrops when they fall onto earth? You must have observed that when it's raining, what happens to the raindrops, children? What happens? 3 things happen to the raindrops when they fall onto earth. Have you ever observed what happens to rainwater, children? I am sure you must have seen that some of this water, they flow on the surface of the earth, right? So they flow on the different places. Let's say that if there are slopey areas like this, you can see that water flows on the surface very clearly, right? So what else happens? Sometimes you must have observed that some of the water that falls onto earth, they are absorbed by the soil particles. They go through the soil particles. Right, children? Certain amount of water, that water is absorbed by the soil particles. Understand? What else? Have you seen muddy puddles? Have you seen muddy puddles? I'm sure you must have seen. So what happens when it's raining? Some of this water that falls onto earth, they gather in different places like muddy puddles. Okay, so what actually happens to the water or raindrops when they fall onto earth? Some of them, they flow on the surface of the earth. Surface of the earth. Understand? Like this. So in slopey areas, it's very easy to observe that some water flows through the surface of soil, right? What happens next, children? Number 2, some amount of water is absorbed by soil particles, right? Okay, absorbed by soil. Understand? So some amount of water flow on the surface of the earth and some other amount of water is absorbed by soil. What happens to the other type of water? What happens to the other drops of water when they fall onto the ground, children? Yes, they gather in different places like muddy puddles, right? So they gather in different places. Gather in different places. Examples, muddy puddles. Okay. So what happens to the raindrops when they fall onto our children? Some amount of this water flows on the surface of the earth, right? Some amount of water is absorbed by soil and some other amount of water is gathered in different places like muddy puddles or in between the cracks present, okay? So in those type of places, these water can gather. Understand? So we are going to observe these incidents using an experiment, okay? We will go see. So our next experiment is find out the behavior of raindrops when they fall down. Now we already discussed about these things. Now we are going to see actually what happens. Understand? So what are the materials we need? The materials we need here given in these pictures. We need some sandy soil and we need some soil with stones and gravels, right? And we need some clay soil and we need a glass tank. Okay, now here we are in this picture, it's a round tank. You can use a normal tank as well, right? And you need to use a small cup with small holes, right? Small holes you have to make in the bottom of this cup. Understand? So we will write down. We need sandy soil. And we need soil with stones and gravel. Stones and gravel. And we need some clay soil. And we need a glass tank. So when you use a glass tank, it's very easy to observe what happens in this experiment, right? The cup with holes. Cup with holes. Understand? Now we are going to see what we are going to do under this experiment, right? Look at this. Now the third step of the experiment is, what is that? Method. So here what we have to do under this experiment, children. Here remember, we use different types of soil, soil with sand, sandy soil, or we have soil with stones and gravel and clay soil. So you have to arrange these different types of soil in the glass tank like this. To the bottom you have to put stones, next layer is gravel, next soil layer is sandy soil, and finally you have to put the clay soil layer. Okay, so when you arrange this clay soil layer, children, you can see you have to prepare it like a small hill so that you can observe how the water flows through the soil layer very clearly. Understand? So what we have to do here, children, we have to take the cup with holes and you have to put some water into this cup and you have to pour water onto these components of soil using the cup with these small holes. Understand? Actually, when this water falls onto these components, you can imagine it's just like raining. Okay, so we are going to create that incident. Okay, it's just like raining, because in this experiment, we are going to see what happens, behavior of raindrops. Understand what happens to the raindrops when they fall down. So here, this incident, falling down of these water droplets from this cup with small holes, it is just like it's raining. Understand, children? So when you do this experiment, you have to observe clearly what happens. You will see some of this water, it goes through the soil particles and will remain here at the bottom. We are going to learn later that that type of water is known as groundwater, right? And like this, some amount of water, it will flow on the surface, and you are going to learn later that is known as surface water. And some other amount of water, what will happen, children? They will gather in different places like this. Okay, they are known as surface water. And this is actually rain. Rain means type of precipitation. We learn all these things when we are doing the experiment, okay, children? So what we have to write here? Set the apparatus as shown in the figure, and pour water onto the components of soil. Now these are the components: stones, gravel, sand and clay particles. Water onto the components of soil. How do you pour water? Using the cup with holes. Using the cup with holes. Understand? Now we are going to do this experiment. So we are going to do this experiment in order to study the behavior of raindrops that falls into ground. Right. So before we go to this one, I hope you remember we discussed about there are 3 different types of water based on availability. What are they, children? That is surface water, groundwater and precipitation. So under this experiment, we can study all these 3 types. So here we have a water beaker and I have a small cup with small holes. And I have this set up here. Look carefully. If you observe this carefully, you will see there are 4 different types of layers in this soil, right? So the bottom layer is stones, next gravel, next we have sand, and then top layer is the clay layer, right? So we can consider, if we take natural soil profile, that would be equal to this one, right? So we are going to see what is the nature of the way the water flows when water falls as rain. So I am going to put this water using the cup. Now children, this equals to rain. So this is precipitation stage. You can look carefully what happens from your side when I pour water like this. What happens to that? The same thing will happen naturally when rain falls. Can you all see how this water flows through the soil? This is equal to rain. So rain is precipitation. That is the first form of water based on availability. Okay, children? So what are the other forms of precipitation? Rain, snow, hail, sleet. So all these things are coming under precipitation state. Can you all see how water flows through each layer, children? And it's very clear some amount of this water, it flows through the surface. You can do it even at home. So can you see here water, it's muddy, right? Because it washes away the soil as well. Right, is it clear, children? So look carefully. Now we already discussed about the first form of water based on availability, that is precipitation, right? Example, rain and snow and sleet, right? So what can you tell about this? Now this looks like you can consider it's a lake or stream, okay? So this is equal to surface water. We learned there are 3 different types of water based on availability. First form is precipitation, next form is surface water. What are the other examples for surface water, children? Waterfalls, right? And streams, oceans, they all come in under surface water. So can you see, if you observe carefully, there's some water remaining between these soil particles, right among the soil layer between the soil particles. Now this is the third type, children. This is known as groundwater. So what are the examples for groundwater, children? Springs and wells, these are the examples for groundwater. So I hope it's very clear. There are 3 types of water based on availability. So what are they? Precipitation, surface water and groundwater. Right, children, did you see the experiment? Did you understand what happened there? I hope you understood very well, okay? So what happened? What were the observations, children? Did you observe carefully? What happened? So when you pour water using this cup, it was very clear. Some amount of water, they go through the soil components, so components of the soil or the soil particles, right? It was very clear some amount of water go through the soil particles. What happens to the other amount? Some amount of water, they flows through the top of the soil or the soil layer. Understand? And another amount of water, they will gather in different places like this. Okay, we will write down that one now. Right. So what happens? Number 1, some amount of water, flows on the surface. And some amount of water what happens? Flows through the components of soil. Flows through the components of soil. So, or soil particles. Number 3. Another amount of water, they will remain on different places on the surface. Some amount of water remain on the soil. Remain on soil. Understand? So what is the conclusion, children? I explained that while I was doing the experiment, I already explained that when that water comes down through this cup, this is rain and this is known as precipitation. Understand? This is precipitation. Precipitation means different methods where water comes to the earth's surface. Understand? So this is precipitation. And when water flows on the soil, when water flows from one place to another place, that is known as surface water. Right? We can see surface water in rivers, streams, oceans, waterfalls. Okay? And some other amount of water, they go through the soil particles, and that is known as groundwater. So groundwater, where can we see in children? We can see in wells, springs, that is groundwater. Okay, so we will write down. So what is precipitation according to this experiment, children? Precipitation means the water that comes through the holes of the cup. Okay, so we will write down that. So what is precipitation then? The water comes through holes and falls on soil. Okay, that is precipitation. The water comes through holes and falls on soil. Understand? And surface water? What is the surface water, children? The water which flows on the surface. Understand? So we will write down that as well. The water flows and remaining on soil. Remaining on soil. Right? The water flows and remaining on soil. Understand? So what is groundwater then? Here, some amount of water flows through the components of soil. That is groundwater. The water flows through the components of soil. Components of soil or soil particles. Soil particles. Understand, children? So, what was the topic again? Find out the behavior of raindrops when they fall down. So, after doing this experiment, the behavior of raindrops is very clear. Isn't it, children? Some of them flows through the surface, and some of this water, they flow through the soil components, and some of this water remains on the surface. Right? So, accordingly, there are 3 different types of water based on availability: precipitation, surface water, and groundwater. Understand? We will discuss about these 3 different types of water more and more, right? So, types of water based on availability, what are they? Precipitation. What is precipitation? Precipitation means that water that falls onto the surface of the earth, right? And next one, surface water. What is surface water? Surface water means that the amount of water that remains on the surface of soil, right? And groundwater means the amount of water that goes through the soil particles or components of soil, or the amount of water present beneath the earth's surface. Understand? So we will go through the examples now. Precipitation. Now tell me, what is precipitation? Precipitation means water that falls onto the earth's surface. Okay. What are the methods, children? What are the different ways of precipitation? Now we all know the most common method of precipitation is rain. Other than rain, what are the other ways, children, that the earth gets water from the clouds? What are the other ways? What about snow, sleet, hail? Those are also coming under precipitation, right? So examples, the best example, the most common example is rain. And other examples also there. Snow, hail, sleet. Understand? So in our country, as precipitation, we always see rain. But in some other countries with different seasons, they experience these other examples as well. Understand? So that is about precipitation. So we are discussing about the types of water based on availability. So the first type is precipitation. So what is precipitation? Water that falls onto the earth's surface. Understand? So examples, rain, snow, hail and sleet. Understand? Now we are moving to the second type. Surface water. Now it's very clear after doing the experiment. What is surface water? Yes, surface water means water that remains on the earth's surface, remains on soil. Okay? Water that remains on the surface of earth. Surface of earth. What are the examples? Any kind of water body that you can see. What are the examples, children? You can see streams, rivers, seas, waterfalls, right? And lakes, oceans, etc. There are so many places where water remains on the surface of the soil. Understand? So, surface water means water that remains on the surface of earth. Okay? So, examples, streams, rivers, seas, waterfalls, etc. Understand, children? It's very clear, right? What is the third type now? Do you remember the third type? Groundwater. What is groundwater now? Water that goes through the components of soil or soil particles or water that present beneath the earth's surface. Okay? So that is known as groundwater. We will write. So water present beneath earth's surface. Earth's surface. What are the examples? I already mentioned this one as well. Do you remember I told you wells and springs? Wells and springs. Those are the examples for groundwater. Understand? Wells and springs. Understand? So we learned there are two different ways that we can categorize water. Number one, based on its state, physical state, like solid, liquid and gases. And the second way we learned is water can be categorized based on the availability. So based on the availability, there are three different types of water. That is precipitation, surface water and groundwater. Apart from this, children, there's another way that we can categorize water. What is that? We will go see. Now I told you there's another type of water, another way that we can divide water based on a certain factor. That is types of water based on salinity. What is salinity? Now this is a new term, I think. Have you ever heard of salinity? What is salinity? Remember, children, now water is a good solvent. Now you know that you can dissolve different things in water, like sugar, salt, and different paints, right? So that is because water is a very good solvent. What is a solvent, children? Solvent is something which can dissolve so many things in that. So water is a very good solvent. Water can dissolve different substances like salt, sugar, medicines. Understand? Therefore, dissolution of different things in water is a special property of water. Okay? So, because of this property, so many salts are dissolved in this water present in natural water bodies. And this is known as salinity, the amount of salts present in water. Understand? The amount of salts dissolved in water is called salinity. Right? So, in some places, the salinity of water is very high. Where are the places, children? What are those places? Where can we find salt water? You all know that we can find from seas, oceans. Understand? Sea water is very salty. Okay, that is because a lot of salts dissolved in the sea water. Understand, children? So, the amount of salts dissolved in water is called salinity. Salinity. So, this is a new term now. Now, you have to memorize this, salinity. So, based on salinity or based on the amount of salts dissolved in water, water can be divided into three main groups. Now, what are they? Remember, there are some amounts of water, they have a lot of salts dissolved in it, like sea water. What about tap water, children? Like fresh water? Is it salty? It's not. When we drink that water, it's not salty taste, right? It means only a very little amount of salts are dissolved. That is why we can't feel that salty taste. Okay? So, there are some other types of water. They have more amount of salt than fresh water, like tap water, but they have less amount of salt dissolved than marine water or the sea water. Understand? So, we will write down these things. There are three types of water based on salinity. Now, the first one is marine water. Water present in seas and oceans. Marine water. The next type is, now remember, brackish water. Now I told you some types of water, they have salt dissolved more than fresh water but less than marine water, right? Brackish water. Now where can we find brackish water, children? In lagoons. In lagoon areas we can find brackish water, right? Brackish water. And the third type is fresh water. Day-to-day life, we use this fresh water. Fresh water. So, we will write the relevant things. Okay. So, when it comes to marine water, a lot of salts dissolved in marine water. A lot of salts dissolved. A lot of salts dissolved here. What are the different types of salts? There are many types of salts. I will give you some examples like sodium chloride, potassium chloride, calcium chloride, magnesium chloride. These are some examples for different salts, children. Okay. And brackish water? Salts dissolved here is less than marine water, but higher than fresh water. Higher than fresh water. Okay. So, where can we find this brackish water? In lagoons. Understand? So, salts dissolved here is less than marine water and higher than fresh water, right? So fresh water, very little amount of salts are dissolved. Salts are dissolved. Understand? So it's very clear. Based on salinity, there are 3 different types of water. What are they? Marine water, brackish water and fresh water. Marine water, brackish water and fresh water. Understand? Now what is salinity again? The amount of salts dissolved in water. Understand? Now we will see another important thing. Look at this. Salt, sodium chloride is produced in saltons by vaporizing seawater. What is this? Now I told you there are different salts dissolved in water. Understand? So where do we get this salt that we eat, children? I told you there are different types of salts, right? So the salt that we eat also comes from the marine water. And another thing is, the name of the salt that we eat. Day-to-day life, we use this salt to cook food, right? There's a chemical name for this one. That is sodium chloride. Now, this is something you have to memorize, okay? So, the salt we eat is sodium chloride. The name of the salt we eat is sodium chloride. How do we produce this sodium chloride, children? From the marine water, from the sea water. How do we do this? Now, look at this carefully. First, we have to fill this sea water into huge pools, right? We have to fill this sea water into these huge pools. These areas are known as saltons, right? So, now here we have marine water or sea water. Right. Now we already know that in marine water, a lot of salts dissolved in water, marine water. So we can write like this, water plus a lot of salt. Right. So in these areas, in these coastal areas with the seas and oceans, what happens? There's strong sunlight. Okay. So because of the sun's heat, what happens, children? When we fill this marine water into pools and when we leave it, what happens? This water gets dried up because of the sun's heat. Right? Water gets dried up because of the sun's heat. And finally, in the bottom of this pool, salt will remain. Okay, when all the water evaporates, finally, only the salt will remain at the bottom of the pool. Okay, so this is how we produce the salt we eat. And after collecting that salt, we have to remove the other impure substances by adding different other chemicals. You are going to learn this process in upper grades. Okay. So, salt or sodium chloride is produced in saltons by vaporizing seawater, by removing seawater. Understand? Right, children? Here we have the same story again. Fresh water, marine water, brackish water. So we know that according to salinity, based on the salinity, we can divide water into 3 main groups, that is fresh water, marine water and brackish water. Right? So what is this, children? This is a river. We will write it here. This is a river. What can you tell about the salinity of fresh water? Salinity of fresh water? Very low. Right? Salinity is very low. It means the amount of salts dissolved in this fresh water is very low. Okay. What about this one? Marine water. Now what is this? This is a sea. What can you tell about the salinity? Salinity is very high, right? So salinity is very high. Okay. Brackish water? Where can we find brackish water? Now what is this? It's a lagoon. In lagoon environments, right, we can find brackish water. What about the salinity of brackish water, children? Yes, I'm sure now you understand. Salinity of brackish water is less than that of marine water, but higher than that of fresh water, right? So salinity is less than marine water but higher than that of fresh water. Fresh water. Understand? So it's very clear there are three different types of water based on the salt. So based on different substances dissolved in it, that is fresh water, marine water and brackish water. The things or the salts present in fresh water is very low, therefore salinity is very low, right? And in marine water, salinity is very high. Many salts are dissolved, right? Therefore it is very salty in taste. Okay, is this salty taste? No, it's not salty in taste, right? And brackish water, salinity is less than that of marine water but higher than that of fresh water. Understand? And you have to memorize what are the places where you can find this fresh water, marine water and brackish water. Okay, so now we are going to do an experiment related to this different types of water based on salinity. Understand? Right. We have the experiment, find out the salinity of water. Now we learned what salinity is. Salinity of water means the amount of salts dissolved in water. Now I told you there are three different types of water based on salinity. What are they? That is fresh water, brackish water and marine water. Right? Remember children, we are going to find out the salinity of water, but here we are not going to use separate fresh water, brackish water or marine water samples. Understand? So listen very carefully what we are going to do. We are going to make our own samples which are equal to this fresh water, brackish water and marine water. How do we do that? By increasing and decreasing the amount of salts we dissolve. Okay, so what are the things we need? Materials, we need salt. We need salt and we need water. This water should be fresh water, right? We need water, normal tap water. Okay, and we need a beaker. We are going to use a beaker of 50 milliliters volume. Okay, what is this children? In this experiment, we have to measure the mass of each sample. Okay, so to measure the mass, we use this instrument. What is this children? This is known as the triple beam balance. Triple beam balance. About using this one, I am going to explain you during the experiment. There's a special way that you have to use this balance. I am going to teach you while I am doing the experiment. Okay, so this is the triple beam balance. Triple beam balance. Understand? So we need salt, we need water, we need a beaker and we need a triple beam balance. How do we do this experiment? We will go see. Method. Look at this table carefully. What we have to do is we have to make three different types of solutions. Solution number one. Now here three instances are there. I'm going to name them A, B and C. First instance, you have to take beaker with water, fresh water, tap water. Okay, so here we are not going to add any amount of salt. Understand? So beaker with water, and using the triple beam balance, you have to measure the mass of the beaker with water. We are going to fill this beaker with 25 milliliters of water, right? 25 milliliters. Remember children, each time under each solution, the volume must be the same. Under each instance, we are going to use the same volume. Okay, this volume here is 25 milliliters. Okay. Understand? Under each instance, we are going to use the same volume, equal volumes. Then only this experiment becomes a success. Okay. So first instance, solution A, you have to pour 25 milliliters of water into the beaker and you have to measure the mass and record it. Second instance, what you have to do, you have to take the same beaker. You have to throw that initial amount of water, right? So you have to take the beaker and you have to put 2 grams of salt. So you have to put some 2 grams of salt into this beaker, right? After that, you have to dissolve this salt in small amount of water. After that, you have to fill this another amount of water up to 25 milliliters. Entire volume, total volume should be 25 milliliters. Now initially no salt, therefore straight away we can pour 25 milliliters of water into the beaker and measure the mass. Solution C. What you have to do here, you have to again throw this water with salt and you have to take the beaker again. Now you have to put 6 grams of salt here. You have to put 6 grams of salt and you have to dissolve it in small amount of water. You have to fill it up to 25 milliliters again. I told you under each solution, under each instance, the volume should be the same, equal, right? So first instance, you have a beaker with 25 milliliters of water, measure the mass, and second instance, you have to take 2 grams of salt and you have to dissolve it in a little bit of water and you have to fill the beaker up to 25 milliliters. Third instance, you have to put 6 grams of salt and you have to dissolve it in water and fill the beaker up to 25 milliliters again. Understand? We will write this down. Measure the mass of each solution using the triple beam balance. Triple beam balance. And each instance, the volume should be equal. Equal volumes. Each solution should have equal volumes, that is 25 milliliters. Okay, I hope it's clear how to do this experiment. Now we are going to do this experiment in the lab. Okay, so you all know that there are 3 different types of water based on salinity. What are they, children? That is fresh water, brackish water and marine water. So fresh water, when you consider fresh water has only a very little amount of salt dissolved in it. right? So what is this salinity actually? Salinity means the amount of salt dissolved in a certain type of water, right? So when we consider fresh water, only a very little amount of salt is dissolved, right? But when we consider marine water has a lot of salt dissolved in it. So when we consider brackish water, the amount of salt dissolved in brackish water is less than that of marine water, but it is higher than that of fresh water. So we are going to do this experiment here in order to study this salinity of water. But remember children, we are not going to use the correct or the real water samples. We are not going to use real marine or real brackish water samples, but we are going to use the real fresh water sample, right? So in order to make these brackish water and marine water, we are going to dissolve different amounts of salt in it. So we'll start the work. First of all, now I told you we have to, in this experiment, we have to use different types of water samples and we have to measure the masses of that, right? So in order to measure the mass, here today we are going to use this balance. This is known as the triple beam balance, right? You all can see there are 3 bars over here with different masses. So you can see this weight here. Its mass is 10 grams and this one 100 grams and this one 1 grams, right? So I will show you how to measure the mass using this balance. So first of all, so this experiment, what we are going to do is, first we are going to beaker, 50 milliliters beaker with 25 milliliters of water, and we have to measure the mass of that. So first we will do that. We have a fresh water sample here and I am going to measure 25 milliliters of water to that one roughly. And we are going to measure the mass now. Now you all can see now this is the pan where we used to place our object that we need to measure, and you all can see this bar, this line aligns with the 0 over here, right? So when I place this here on the pan, what happens? This bar goes up, right? So till this line, this bar goes aligned with these 0, you have to move these weights here and there. That is the method of measuring the mass. So first I am going to start with the largest one. It's 100. So it goes down. It means it's too much, too heavy. So then I am going to use the second one. 10, 20, 30, 40, 50, 60. Now, when I put it to 60, you can see it goes down. It means the mass of this beaker with water should be less than 60. So I am going to put it to 50 and then I am going to move the smallest weight. Watch carefully children. So when you go to the lab in your schools, you also can use the triple beam balance like this. So I think this line aligns with 0 now. It stop moving. Right? So we can roughly take, you all can see this weight is in 50, this one is in 9.4, right? So what is the mass of these 25 milliliters of water with beaker? The mass is 50 plus 9.4, 59.4, right? So the mass is 59.4. Now what do we have to do is, I'm going to put them back. Right. Now we have to remove this water and then we have to measure 2 grams of salt. So this is the watch glass. I am going to take salt into this one. When I place this here, I am going to first take the mass of this. Here So it should be less than 40. Therefore, I am going to take 30 and move in the smallest weight. Right. So you all can see here, this weight is in 30, this one is in 9, and it aligns with each other. I told you we have to measure 2 grams of salt. So to the same pan, right? So in order to change this to 2, I have to add another 2 grams to this one. So now this is 39, 39 plus 2, 41. Therefore, I am going to adjust this to 41 using this bar. Right. And till these two lines align, I am going to add salt into this. Right. So those two lines align. So we have 2 grams of salt here. Now I need to take an empty beaker, the same beaker. We need to empty it, and I'm going to put this salt, 2 grams of salt into this one. And we are going to add a little bit of water, fresh water into this one, and dissolve this really well. And finally, you have to level this up to 25, because that is the amount of water we are going to take under all 3 instances, right? Under fresh water, marine water and brackish water, we have to take the total amount should be, the total volume should be 25 milliliters, right? So I am going to level it up to 25. And dissolve real well. Children, now I need to measure the mass of this water sample. Now this water, 25 milliliters of water after leveling it up, but I added 2 grams of salt into this. We are going to measure the mass of this as well. So I'm going to move these bars back, and we are going to place this over here. So I'm going to move the first bar, 100. So it goes down. It means the mass of this setup is less than 100. I'm taking it to 60. If I take it to 70, it goes down. It means 70 is not there. It should be less than 70, right? So to 60, and then I'm going to move the small bar. It's too much again. Right. Likely align. Does it align with each other, children? Yes. Yes. So we can take here, I have 60 plus 1.5. So we will take it as 61.5. Okay. So as I mentioned you earlier, we have the water sample where we dissolve 2 grams of salt. The mass of it is higher than that of the earlier water sample. Right. Now we need to take 6 grams of salt. Right. Now here I previously measured it. We have 6 grams of salt and we have to dissolve it in another water sample. Right. So I am going to remove this water into a different beaker. I'm going to use the same beaker and I'm going to dissolve this amount of salt in a little amount of water first. You should make sure you take the entire amount of salt you measured. And then I'm going to dissolve it in fresh water. I'm adding some more water and dissolve the amount of salt really well. Right. And finally, after dissolving it, I'm going to level it up to 25 milliliters. Right. So you all can see it's 25 milliliters. I'm going to dissolve it more. Now I need to measure the mass of this water with 6 grams of salt. So we will do this. So I'm moving this bar. Earlier it was 61.5, so this also should be somewhere closer to this value, 70. So it has to be less than 70 because this bar goes down. Right. I think I have to add some more. Maybe another unit. Can you all see, children? It aligns with 0 or not? It's likely aligned with 0, I think. Right, so we'll nearly take this value. So here we have 60, here we have 3.4. Therefore, the mass of this water sample is 63.4, right? Right, children. So we measured 3 different types of water samples. The first water sample was fresh water sample. We did not add any amount of salt into that one, right? So what was the mass of that amount? 59.4, right? That sample of water was 59.4 grams, right? So secondly, we took another water sample where what we did was we dissolved 2 grams of salt and we leveled up the water up to 25 milliliters and we measured the mass of the water sample, right? And what was the mass of that one? 61.5 grams, right? And the third water sample contains 6 grams of salt, right? So what was the mass of the last water sample? It was 63.4, right? So what is the theory behind these 3 water samples and their masses, children? We can say that the first water sample, it is actually fresh water, right? And we added 2 grams to the second water sample and to the third water sample we added 6 grams, right? So when we consider the mass, the heaviest one was the third water sample. So we can consider the third water sample is equal to marine water because in marine water more salt is dissolved, right? When you consider fresh water, only a very little amount of salt is dissolved, right? You can't feel any salty taste there. But when you consider brackish water, it doesn't have that much of salt as in marine water, but it is saltier than that of fresh water. So we can consider the second water sample as the brackish water sample, right? So what happens when the amount of salt dissolved in a certain water sample increases? When we take the same volume of water, the mass of the same volume of water with different types of different amounts of salt contains in it also changes, right? So mass of the fresh water with no salt, it was least heaviest, right? And when we consider the marine water sample with 6 grams of, here according to this one, the 6 grams of salt, it was the heaviest, right? So I hope it's clear when we consider the salinity of water, when the amount of salt dissolved in water increases, the mass of the same amount of water also increases. Right, children? Did you see what happened there? I hope you observed the experiment carefully. What happened, children? You know that we took the solutions like this. The first solution, beaker with water. Second solution, beaker with 2 grams of salt dissolved in water. And the third one, beaker with 6 grams of salt dissolved in water. And we measure the masses. The mass was highest in beaker with 6 grams of salt and the mass was lowest in the first solution without salt. So what is the conclusion, children? When the salinity increases, when the amount of salt increases, what happens to the mass of the same or equal volume of water? That also increases. Understand, right? So beaker with water, here the first one, it has the lowest mass, and beaker with 6 grams of salt dissolved water, it has the highest mass. And another thing, children, I even explained it during the experiment. When we take these 3 water samples, we can assume that this is the fresh water sample, this is the brackish water sample, and this is the marine water sample. We know that in marine water, a lot of salts dissolved in it, right? And in fresh water, only a limited amount of salts dissolved in it. Okay? And here in brackish water, salinity is less than that of marine water but higher than that of fresh water. Understand? So what is the observation? When the amount of salt increases, what happened to the mass? Mass also increases. Each time we use the same volume of water, even though we took the same volume of water, because the amount of salt is different, the mass also is different. Understand? Shall we write it now? Okay. So observation is, when the amount of salt dissolved increases, when the amount of salt dissolved increases, the mass of the equal volume of water, increases. Understand? When the amount of salt dissolved increases, the mass of the equal volume of water also increases. So what is the conclusion? The conclusion is, when the amount of salt increases, so based on salinity, the mass also changes, right? Here when the salinity increases, mass of water also increases, right? Mass of water increases, mass of water increases with salinity. Right? Mass of water increases with salinity. That is the conclusion. So this is a very good method to identify a given freshwater, brackish water and marine water sample. Let's say we have 3 different samples but they are not labeled. So we don't know which one is fresh water, which one is brackish water, and which one is marine water. So the easiest method is you have to take each water sample equal amounts, right? Let's say you can take 50 milliliters of fresh water, 50 milliliters of brackish water, and 50 milliliters of marine water. When you measure the mass of those water samples, marine water sample's mass is higher than the other two samples. Understand? So within brackets we can write that as well. This can be used to identify. This can be used to identify. This can be used to identify fresh water, brackish water, and marine water. Okay. Right, children. Now remember, we did this experiment to identify fresh water, brackish water, and marine water, or their salinity. But here we did not use the true water samples. What we did was, we changed the amount of salts dissolved in each sample. Okay. Now we are going to do the same type of experiment using real water samples. Okay. Right. Right, children. We have the next experiment, the same experiment. Now we are going to use real water samples, actual water samples, right? So what do we need? We need some seawater, or we need marine water. We will write seawater, within brackets I will write marine water, right? Marine water. And the next one, we need some well water, which means fresh water. Well water or fresh water. Okay. And we need water taken from a lagoon, right? Straight away right here, brackish water. And we need a beaker. And we need a triple beam balance. Triple beam balance. Right. So what do we have to do? It's very clear now, because we did same type of experiment. We have to do the same experiment, but here with the real water samples. Okay. So the method. What we have to do here, look at this table given, situation and mass. You have to take seawater, well water, brackish water. Remember, each time you have to take equal volumes of water samples. If you take here 25 milliliters of seawater, you can't take 50 milliliters of well water. That also should be 25 milliliters. Okay, so you have to take the same or equal volumes of water samples, and you have to measure the mass using the triple beam balance. Understand? Right. So we will write that. Measure the mass of equal volumes. Equal volumes of water samples using the triple beam balance. Triple beam balance. Now you know how to use a triple beam balance, right? Triple beam balance. Measure the mass of equal volumes of water samples using the triple beam balance. Okay. Now I am sure you can assume what will happen when we are doing this experiment. So we will go see, right? So you all know that there are 3 different types of water based on salinity, and we know that based on salinity, the mass of a certain amount of water sample also differs. So here we have 3 different types of water samples. This is marine water, this is brackish water, and this is fresh water, right? So this brackish water taken from a lagoon and fresh water taken from a well. And we are going to measure and find the differences of these masses of these three different types of water samples. First, we'll start with the marine water sample. So we are using the triple beam balance and placing it like this. And I'm starting with the first one. Right, it means it's less than 200. I'm using the 100 weight. So you have to move. Check whether it aligns with 0, children. Now you all know how to use this balance. We did one experiment with this. So we'll take the round off value, otherwise it takes a long time. I think we can take this value, children. We will take, it is here 100, 104.7, right? So 104.7, this is the marine water sample. Now we are going to take the brackish water sample. We all know that the amount of salt dissolved in brackish water, it is less than that of the marine water. Right, so this place goes up. So we know that this should be less heavier than the marine water. Therefore, still I am using the 100 one. So I think it's nearly I'm going to take 103.6. 103.6. So the mass is less than that of the marine water sample. So now we are going to measure the fresh water sample. I'm using the 100 weight first. So this time it's too much, right? So we can't use the 100 weight anymore. I'm going to put it back and I'm going to use the last bar from here. And I put it 90. I think 90 would work. So we can take it as about 95. Now here it's in 90. Here it's in 5.5. Therefore, we can take the mass as 95.5. So we can prove that. What can we prove using this experiment, children? Now these are natural samples. Earlier we used 3 samples equal to these natural samples, natural water samples, but we used it by dissolving salt. Now these are actual samples of marine water, fresh water and brackish water. So when we take these 3 samples, it's very clear that mass of the brackish water sample is higher than that of the mass of the fresh water sample, and mass of the marine water sample is even higher than that of the mass of the brackish water sample. Okay, did you see the experiment, children? So it's very clear, right? What happened when you measure the masses of these 3 different water samples? Which sample had the highest mass? It was obvious. The sea water sample had the highest mass and the well water sample had the lowest mass. Okay, so we will write down observations. So the mass of water, how did it change, children? I will write like that. Well water. well water sample had the lowest mass. The mass of water changes like this. It's easy to understand it. So what is the next water sample with the next mass? That was the lagoon water sample. Here, look at this one, brackish water or lagoon water sample. Okay, brackish water sample. Brackish water sample. And seawater sample had the highest mass, right? Seawater. Understand? So it's very clear the mass of water changes like this. So the lowest mass with well water sample and then brackish water and finally seawater has the highest mass. So what is the conclusion? In the previous experiment we learned that mass changes based on the amount of salt dissolved in it. So well water has the lowest mass, seawater has the highest mass. It means seawater has the largest number of, the highest number of salts dissolved in it. Therefore, the salinity is highest in seawater, right? We will write that. Salinity is highest in seawater, right? What about brackish water? In brackish water, salinity is lower than that of seawater but higher than that of fresh water. In brackish water, salinity is lower than seawater. Here seawater means marine water. Right? I will write it. Marine water. What about well water? It has the lowest salinity. Now well water means fresh water. Right? Well water. Or fresh water here has the lowest salinity. Understand? So that is a conclusion. After going through all these masses, we can come to a conclusion that salinity is highest in seawater, and in brackish water, salinity is lower than seawater, and in well water has the lowest salinity. Understand, children?